Hi, my name is Vin Sharma. I'm the GM of Machine Learning Inference Services at AWS, including SageMaker Neo and Elastic Inference. Today, I'll be talking about how AWS can help ML developers overcome common challenges of operating ML models on a fleet of edge devices by using Amazon SageMaker Edge Manager. Enterprises can solve a number of business problems by deploying machine learning models on a fleet of edge devices. For example, running an ML model allows an operator of a fleet of wind turbines or oil rigs or security cameras to predict the failure of a component on a particular device in the fleet and send out a technician only when needed, which reduces the maintenance costs. We also see AWS customers who manufacture PCs and tablets using ML models to personalize the experience of the device users based on their usage profile. And some AWS customers who manufacture medical devices deploy ML models to help detect objects of interest in the medical images and videos, which helps the doctors focus on the most relevant test results first. Sometimes, running an ML model on an edge device is not only the best, but perhaps the only way to solve a business problem. For example, running the ML model on a device rather than on a remote server in the data center allows the operator of a fleet of video security cameras to get results back immediately and preserve the privacy of the end user and lower the cost of network connectivity to only the most essential data transfer. These are some of the most frequently cited reasons for deploying ML models at the edge. First, use cases that require real-time latency and predictions, as in autonomous vehicles or robots. Second, use cases where you can preserve the privacy of the device users by keeping their personal data on the device instead of sending it elsewhere to the cloud. This is particularly true with personal devices like PCs, laptops, mobile phones, and smart cameras and smart speakers, which collect images or sounds from the ambient environment. Third, the devices may not always be connected. The device may operate on a farm, an oil rig, or even a satellite in space where connectivity may be too expensive or simply non-existent. Finally, we're also seeing an explosion in the number of low-power edge computing hardware designed for machine learning, which makes it possible for complex models based on neural networks to run at the edge. Today, over 750 million devices equipped with ML acceleration hardware are being sold annually and forecasted to grow to about 1.5 billion devices by 2024, according to market research reports. But the central problem is that what works for a few devices does not work for a fleet of devices at this scale. If you deploy ML models on a Raspberry Pi, hundreds of video security cameras, or even thousands of robots today, you simply cannot do the same thing or more of the same thing to operate ML models in a fleet of millions of mobile phones or laptops or smart speakers. Or you might not be able to do the same thing when you have data coming from sensors connected to hubs, connected to industrial machines in an IoT deployment. To make it easier to operate ML models in production at scale on a large variety of edge devices, AWS is excited to introduce Amazon SageMaker Edge Manager. This service makes it easy for ML developers to prepare, run, monitor, and update machine learning models on fleets of edge devices such as smart cameras, smart speakers, robots, and industrial machines. Edge ML developers face unique challenges. The first problem is that machine learning models, particularly deep learning models, can add a lot of functions, operators, and parameters when they build an internal representation of the data in order to make predictions based on that representation. As the number of parameters and functions increases, so do the compute resources required to run that model with high performance. And unlike servers in the cloud where compute resources are abundant and elastic, on edge devices, the constraints on compute, memory, and connectivity can be prohibitive. This makes running machine learning models on edge devices particularly challenging. Today, many edge ML developers use either hardware-specific tools or framework-specific tools to convert and optimize their trained models to run on the target hardware. And this can take many months for developers to hand-tune each model to fit within the specific hardware constraints of each device. SageMaker Edge Manager makes this easy by using Amazon SageMaker Neo, which compiles the models for a wide variety of target devices and for a wide range of operating environments, including Linux, Windows, Android, and even iOS and macOS, across a variety of target hardware based on CPUs, GPUs, and embedded hardware SoCs. These compiled models can run up to 25 times faster for certain models on certain target hardware. Once the model is compiled, the SageMaker Edge Manager service signs each model with an AWS key and packages the model with its runtime and all the credentials needed to run it on a particular device. Then you can use AWS IoT Greengrass or your own deployment mechanism to deploy the model to your edge device and distribute it across the fleet of devices. This brings us to the second problem. Many machine learning applications need to run more than one model at a time. For example, that delivery robot needs to run a perception, navigation, and control model all working together in order to navigate its environment. For complex use cases like this, you need to be able to run several models in series or in parallel, but running a model today involves executing the model in its source framework like TensorFlow or PyTorch, and each framework requires a lot of hardware resources to run, which adds a significant overhead to the cost, the computational cost of running the model, and also to the latency, the responsiveness of the model to the requests. Now, if you need to run each model in its own framework, and each framework takes up a lot of resources, you end up with either a very resource-rich but rather expensive machine, or one on which you can only run one model at a time, and that doesn't help with the application that you're looking to deploy. SageMaker Edge Manager brings the concept of a model server to the edge device, allowing you to write a simple application logic that can request responses from several models that can be loaded by the model manager component and executed in parallel or in series. And in this way, it balances the model across the hardware resources and improves the utilization of the device hardware. After deployment, the model gets copied onto each device. Each model copy in the wild encounters real-world data that's different from the one on which the original model was trained. Which brings us to our third problem, which is model quality decays in production over time. And the pattern of real-world data drifts from that of the training data, and this causes incorrect predictions. For example, that same delivery robot trained to avoid obstacles in the lab might produce a growing number of errors if the route layout changes or the circumstances of the environment changes. Edge ML developers need to be able to monitor their models continuously in order to ensure the quality of the model instances when the accuracy of the model determines the accuracy of the application, which is very business critical. SageMaker Edge Manager provides the foundation for your continuous integration and continuous deployment of machine learning models for edge devices. Using the service, you can easily collect model metrics and sample input and output data from each model on each device in your fleet and send the data securely to the cloud for monitoring, for labeling, and, if necessary, retraining the model. You can also configure how you want to sample the data based on the application. For example, you could sample it either once a day or only when an event is triggered at the edge device. And in the cloud, you can then gauge the health of your model across the fleet using the dashboard. This allows SageMaker Edge Manager to continuously monitor the heartbeat of every model on every device in your fleet. In the cloud, you can gauge the health of your model fleets from the dashboard. You can use the model monitor to use your own drift detection algorithm to detect model quality decay or identify specific devices and models that are causing the decay. You can then use SageMaker Ground Truth to relabel the data that you've collected from the devices, retrain your model with the new data, and then redeploy the model using the same deployment mechanism you had previously. In summary, SageMaker Edge Manager reduces the time and effort needed for Edge ML developers to get models into production and makes it easy for them to continuously monitor and improve the quality of the models across their fleet of devices. Thank you for listening.